going to show one more counter operation, that is hexadecimal down count. Okay, we are writing 8051 assembly language program for implementing hexadecimal down counter. So I already explained hexadecimal up counter. I will show how to convert the same program for down counter. So for down counter, you have to stop the previous program and you have to modify the program. So now you give this as a down counter. Then initially the counter should you have to give from 0 FF. Okay, 0 FF. Don't give directly FF. If you give directly FF, it come in black color. Observe, it will at the compile it will give error. You can see here undefined symbol in the line number 3. That's why all data starting from A, B, C, D. Okay, hexadecimal A or B, C, D, E, F. Any data starting from A1 or A2 or B1, B2, you have to give starting 0. Okay, then if it is coming in red color, it is correct. Okay, or you can also type 0xFF also. Okay, 0FFH, or you can also type 0xFFH or 0xFF. All are correct. Okay, 0xFF is also correct. 0FFH is also correct. Okay, so move for P0 comma A means accumulator content that FF will go into port 0. After that, we are calling a delay program. Same delay for all the programs, all the 4 programs. Same delay you have to learn. Okay, I told how to remember this. Okay, first load R1, R2, R3 with FF. It depends. If you want a little bit delay less, you give instead of FF, you give 5F or 6F or something. First R1, R2, R3, decrement the DJ and Z you have to use. This order is reversed. Here it is R1, R2, R3. Now R3, R2, R1. And you have to use 3 labels. DJ and Z R3. L3 is same line. Next L2 is above that L2. Next L1 is this. L3, L2, L1 here. In the DJ and Z, L3, L2, L1. Here L1, L2, L3. See here L1, L2, L3. Same line L3 should be there. Here L3, here also L3. You remember L3 this line, then you can observe. From this L3 above you write L1, L2 above that L1 you write. This L3 below you write L2, below you write L1. Okay. After that, add A01. So now instead of add, you can use SUBB. You can use SUBB, subtract A you can use, or you can also use add FF also you can use. I'll show both. Okay. So build targets, save it, build target, and start debug. So I'm running this program now. CFF, FE, FD, FC, FE. It is decreasing, down counting, and it will count up to 0, 0. Okay. After that, after 0, 0, again it will loaded with FF. Okay. This is down counting. You can also instead of sub, okay, instead of sub, if it is sub, no, if it is sub, you have to write A is equal to A minus 1. A is equal to A minus 1 for subtraction. Or you can also use add A comma, same FF only you can use. FF only. I told the calculator in the hexadecimal mode. If you take FF, add with FF, you'll get FE. Only this 8-bit will display in the port 0. So FE. Again, for this FE, add FF, you will get FD. Only this will be displayed. Okay. So again, FD added with FF, FC will come. So like that, for this program also it will work. Instead of sub A by 1, you can add only instead of sub. Okay. So I'll show this. I will reduce the delay so that you can observe faster. I will give, save it, build target, start debug. So now it will actually reduce the count here. Instead of 9f, I given 5f. Even if you give 2f and 3f, it will count faster also, so that you can get the 0 0 faster down counting. So I'm running this. FF, FE, FD, FE, FC, FA. You can see the count is faster now down counting. Still you can give 4f or 3f. Still faster it will decrease. That means just it will just reduce the delay between the count. If you want more delay, give the more value. If you want less delay, give less. Okay. Thank you. Finally, we'll get 0.